1972, a crack commando unit was sent to prison by a military court for a crime they didn't commit. These men promptly escaped from a maximum security stockade to the Los Angeles underground. Today, still wanted by the government, they survive as soldiers of fortune. If you have a problem, if no one else can help, and if you can find them, maybe you can hire
Mr. Moore! Good afternoon, evening, morning. It could be 2 a.m. in the morning. Who knows? Who cares? As long as you're watching the maths class and you're sitting in the comfort of your own couch, ready to learn from me, Mr. Moore, myself. Alright, we've got plenty to get through today. We're going to be going through average rates of change, and we're also going to be going through instantaneous rates of change. So make sure you get yourself a hot chocolate, you maybe grab a pen and a piece of paper to jot down some notes, and let's get stuck into it. Alright guys, so before we go on any further with anything, we've got to just make sure that we remember stuff from last lesson, alright? And that is rates of change is equal to gradient. Really important that we actually remember that. The rates of change is equal to actually the gradient. So basically when I say rates, it means gradient. Now, a number of you have requested that I can maybe come up with some songs for this video to help you remember things. So I've actually gone to the liberty of doing this. Alright, it's pretty straightforward. Maybe you can even sing along with me. You'll probably pick it up pretty quick. Alright, so DJ, drop that beat.
Let me see those hands together. Hand on out. Hey, everybody jump.
Now when I say rates, you say gradient. Rates.
Gradient.
Rates.
Gradient.
Now when I say rates, you say gradient. Rates.
Gradient.
Rates.
Gradient.
Now when I say rates, you say gradient. Rates.
Gradient.
Now when I say rates, you say gradient. Rates.
Gradient.
Rates.
Gradient.
Alright guys, I hope you jumped in and sung along at home. Big thank you to Jerry for getting back on board with us. Now, hopefully you'll remember from now on when I say the word rates of change, it means actually to find the gradient. So if I say find the rate of change, it means find the gradient. Alright, let's get it stuck into the lesson. Okay, so we're actually going to learn about average rates of change to start off with. Now in order to do that, what I'm going to do is I'm going to take some footage of some real data of me driving from here at school back to my home. Alright, let's go.
And I'm off. Okay, watch me go. I'm like Schumacher running late for the birth of my first child. Now as you can see, there's plenty of things going on the screen. Up the top left hand side you've got my speedometer. Just to the right of that you can see the time. Noting that I've actually sped it up because I didn't think you want to watch all 8 minutes of the movie. Just below that you can see my odometer keeping track of how far I've travelled, and at the very bottom you can see the picture of what I'm actually looking at as I drive along. On the right hand side is the distance time graph keeping track of how far I've travelled over what time. Now this is actually the fastest leg of the trip. You can see that by the steepness of the gradient. I'm just about to pull in and have a stop, taking note that as I stop the line comes to a flat line because I'm not actually travelling anywhere, which means my distance isn't changing. Okay, having a little dance to Hamish and Andy, and the lights are green. Turning right now, speeding back up, you can see this once again because the gradient is steeper again. Pulling into my streets now, and by the looks of things I might even be home in time for dinner. Boy, Jerry will be happy.
Okay, so we're going to have a look at average rate of change. Now, as you can see over on the right hand side is a copy of the graph that we've just taken where y is equal to distance in kilometres and x is equal to time in minutes. Okay, so the questions ask us this: find the average rate of change over the first 4 minutes. Now, average rate of change, you need to remember, is equal to gradient, because when I say rates, you say gradient. Alright, good. Now, looking at this, to find the gradient, we need to, of course, do the rule m is equal to y2 minus y1 over x2 minus x1. As you can see there. Now, of course, we need to find our x2, x1, and our y2 and our y1. Okay, well, let's have a look at that. So, let's have a look at the first point, and that is, will be at 0, because that's the first part of the thing will be at 0, so it's 0, 0, and the next point will be at 4, And from the graph, we go along up to 4, go up along here, coming up to 4, we go across, it's equal to 2.5 kilometers. So 4, 2.5. Okay, let's substitute this into the equation. So m is equal to y2 minus y1, so this is y2 and this is y1. So 2.5 minus 0 over 4 minus 0 is equal to 2.5 over 4, which is equal to 0.625 kilometers per minute. Therefore, the average rate of change over the first 4 minutes is 0.625 kilometers per min. Now the next question says find Mr. Moore's average speed between school and his house in kilometers per hour. So the average speed is equal to average rate of change. Okay, well how long did it take me to get from my house to school? Well, let's just say it took approximately 7 minutes. Alright, and how far did I travel? Well, I travelled 4 kilometers. Okay, so remember you need m is equal to y2 minus y1 over x2 minus x1, so you need 2 points. Alright, so let's have a look at our first point. Our first point will of course be 0, 0 again, and our second point will be 7, 4. Let's substitute these points in. M is equal to y2 being 4 minus y1 being 0 over x2 being 7 minus y2 being 0 is equal to 4 over 7 kilometers per minute. Okay, so this is approximately equal to 0.571 kilometers per minute. Okay, now of course there are 60 minutes in an hour, so what we're going to do is we're going to do 0.571 times 60 kilometers per hour, which is approximately equal to 34.29 kilometers per hour. Therefore, Mr. Moore's average speed was 34.29 kilometers per hour. Okay, so that is, if I do a straight line from here to here, the gradient of this line would be equal to 4 over 7 kilometers per minute. When you convert that into a kilometers per hour units, you end up getting 34.29 kilometers per hour. So my average speed was 34.29 kilometers per hour.
Okay guys, well we know my average rate of change, that is my average speed from work to my house. But isn't anyone interested in the fastest speed, maybe my top speed? Right, this is where the instantaneous rates of change come into play. Instantaneous rates of change, unlike average rates of change, are at a set given time. So for example, before we looked at my average speed between one point and another point, what I want to know for an instantaneous rate of change is how fast am I going at, say, 10 seconds. That's called an instantaneous rate of change.
Now, if you have a look at my speedometer up the top left-hand corner, what that's actually telling you is my instantaneous rate of change, that is my instantaneous speed. So, stopping the picture at exactly 3 minutes and 23 seconds, you can see that my instantaneous speed, or my instantaneous rate of change, is exactly 76 kilometers per hour. So, as can be seen on my speedometer, my instantaneous rate of change, or in other words, speed, is constantly changing as I either speed up or slow down.
Now, to understand instantaneous rates of change, we actually need to know about a thing called a tangent. Right, a number of you probably heard the word tangent before, maybe like I've gone off on a tangent. Now, I know I used to hear about this all the time when I was back in English, alright? My English teacher used to write, start off really well, but then you found a little topic and you went off on a tangent, alright? Actually, I probably do it in class probably too much as well, where I go off on a tangent. Now, a tangent is this. I'm going to use my little flying fox. This is what I used to play with as a kid. It's basically a sock with a tennis ball in it. Alright, I'm going to use this flying fox to explain how a tangent works. Now, basically, this flying fox is continuing around because I'm holding it in the one spot. But as soon as I let it go, it's going to continue off in a straight line, imagining that there was no gravity. So let's have a look. Continue off in a straight line. Alright, it's gone straight up because at the point where I let it go, it was heading up in that direction. So it continued straight up. Alright, so I'm going to demonstrate a tangent just one more time. Alright, remembering a tangent is when it goes off in a certain direction, it continues along that path. Alright, let's go.